Very good afternoon, students. Welcome to the class Basic Electrical Electronics Engineering. So today lecture is about capacitor and capacitor in series and parallel. Okay, so just we'll go to the overview of the capacitor. So first we'll talk about the what is meant by capacitor. Okay, so capacitor, a two-core conducting surface separated by insulating material, is called a capacitor. Okay, so capacitor is a two plate conducting plates. Okay, so a two conducting surfaces separated by an insulating medium. Okay, so an insulating medium is called as a capacitor. So here is a two plates which are the separated by one insulating medium. So this insulating medium we are called as a dielectrical medium. So we'll call as a dielectrical medium. So here in between, so here this is called as a dielectrical medium. So the properties, so the any tool, so it will having the metallic plates. So it is considering as a these are metallic plates. So any two conducting surfaces separated by an insulating medium is called as a capacitor. So not only for this, okay, so here the capacitor, okay, so capacitance is not only between the two conducting plates here, so we can find in the electrical in overhead lines also. Okay, so here we can see in the lines. So suppose if we are having in the outside of the home, we can see the lines. Okay, so these are the distribution line. So here they are having the conductors. Okay, that is the ACSR conductor. Okay, so in between also. Okay, so in between having where current is flowing through these conductors. So if the 3 wires or 4 wires, whatever it may be. So here, if the current is flowing through this conductor and air is in between there. Okay, so here also the capacitance is take places. Okay, so here also the air is act as a dielectrical medium. So here is a one type of the capacitance is there. Okay, so conducting plates. Okay, so here the conducting plates, the insulating medium which is called as a dielectrical medium. Okay, dielectric. So here the ability of the capacitor. So what will do, the capacitor will store the energy, okay, in the form of charge. So capacitor will store the energy in the form of charge. So either here we can see the positives, in other that will having the negative. Okay, so that will be in the form of charge particle. Okay, and if the, okay, depends upon the area of the, okay, so the charge, okay, the capacitor of the store energy charge particle is the depend upon the area in between the, that is distance between the these two plates, and whatever the nature, and here whatever the insulating medium we are using. Okay, so based upon that one also the charge, okay, the charge storage capacity also is varies. And here mainly we are using the dielectrical medium, that is a insulating medium in the charge is mainly used as a, that is the air and paper capacitor. Okay, so air and paper, and some of the cases impregnate paper. Okay, so impregnated paper. So here air is also we can, so in the outside of the in transmission line, overhead line, so here is air also act as a one dielectrical. So in, if we take the cylindrical capacitors, okay, so at that time also we can find the two conducting plates and is the air. Okay, so some cases air will be there and paper impregnate. So paper is the one form. Okay, so here impregnate paper nothing but, so which will be, okay, so here is the, if the dipped in oil, okay, the paper which is dipped in oil, that is called as a impregnated paper. Okay, so how the capacitor work? Okay, so how does the capacitor store the charge? That is the, if the capacitor is having the a switch, and here we are connected the one battery source. Okay, so positive side and negative, here is we place the one switch. So here is the conduct, we are considering that these are the two parallel plates. So if the two parallel plates and we are placing the in between, that is a insulating medium, that is a, we can say that's a air. So when the switch is okay, here we can say that this is the switch S. So whenever the switch is S is open, there is no current flowing. Okay, there is no charge part. So when the switch is closed, okay, so when we close the switch, so here whatever the voltage, okay, so up to that, so positive to, so at the A, okay, the charge particle will stored at that, okay, at the B side the negative charge particle. So until, so how at the at what voltage it can be. So if the voltage, if the having the 12 volts for this voltage source, okay, up to that potential voltage source, okay, up to the potential difference the two plates until reach, okay, so charge will be continuously flow there, okay. If the distance is increasing, okay, the charge voltage also is increasing. So this is the how it will be stored. So then if you remove this, okay, if we remove this one, what will happen after charging, okay, so if you remove this one, so what will happen, so it continuously charge. So here we can say this is a charge. So simply uh, we can see the particle is that whenever we switch is open, so there is no charge fill, okay, when switch is closed, then it's charging their self, okay. So after the charging, if the switch is open, the charge is stored in, okay. So how can we test is a practically if the capacitor is charging or is it working or not, okay. Simply if the in your domestic also any if the capacitor is working or not, okay, so here the positive and negative nodes are there, okay. So for capacitor it will having the positive and negative, and simply by connecting the any voltage source, okay, so by connecting energy source, and then after some time, so remove the capacitor, okay, so remove the voltage source and just connect the both, okay, just connecting the two wires, okay, combining both wires will get the spark, okay. So combining that will get spark. So if the spark is producing, okay, if the connecting positive negative wire, that means here this capacitor is perfectly storing the charge, okay. So if the charge, okay, in the form of not, so if sparks is not produced means, so this capacitor is filled, okay. If the spark is producing while connecting the positive negative means it is the capacitor is working. If the spark is not produced means it is the capacitor is filled, we can assume. Next we'll go to the capacitance. So capacitance is the ability of the capacitor to store the charge is known as the capacitance, okay. Capacitance is nothing but which store the charge, okay, that is nothing but a capacitance. So here the charge, okay, it has been the charge which is stored in the capacitor is directly proportional to the potential difference occur, okay. The charge we can indicate with the Q, okay, which is directly proportional to the potential difference across the plates, okay. The charge will be in the Q and directly proportional to the potential difference, that is the voltage difference between, okay. So Q is directly proportional V, and here we can say Q by V we are characterized as a C, okay. C is the constant, so whatever the C is called as a capacitance of the capacitor, okay. So here the constant C is called as a capacitance. So also we can define the capacitor set as the ratio of, okay, the ratio of the ratio of charge on the capacitor plates to the potential difference across the, okay, the ratio of charge on the potential, okay. So whatever the charge part is there, okay, so the ratio of charge on the capacitor plates to the voltage difference, okay, to the potential difference across the plates is called as the capacitance, okay. is called as the potential difference. Okay, so potential difference across the plates is called as the capacitance. Okay, the units is that is the farads. So for capacitance the units are farads. So mainly all the capacitors is mainly in the micro. Okay, some cases we can find the picofarads also. Okay, so 1 farad is equal to, okay, so in the 1 farad is equal to 1 coulomb for volts. Next we'll talk about the insulating medium in between the capacitor plate. Okay, so we'll talk about the here the insulating medium. Okay, so the insulating medium it can be in the, that is the air, paper, impregnate paper, oil, it may be there. Okay, so here, so how it can be? So the insulating medium also plays the main roles of the storage capacity of the capacitor. Okay, so there is the sum kind. So in the resistor, okay, so resistance also we are having the sum problem. Okay, so that is the ohm, conductivity, resistivity. Okay, so we have replaced the rho. Okay, so in the inductor also we are having the okay. So similarly in the capacitance, so we are having the dielectrical. So in the capacitors also we are having the dielectrical. So here is the having, that is called as the, we can say the insulating medium is called as the dielectrical. So the dielectric constant. So let me talk about the dielectric constant. So if the air is there, okay, it will having the some value. So that value is called as the dielectrical constant. So dielectrical constant means, so ability of the dielectrical medium material to concertain electrical lines of, okay, so if the two plates is there, okay, so the electrical force, okay, lines of force, okay, so the ability of the dielectrical material to concentrate dielectrical lines of force in between the two plates of the called as the dielectric constant. Okay, dielectric constant. So for dielectric constant of the air, okay, so if the air is the insulating medium in between the two plates, so the air value, so we'll having the 1. So okay, so dielectric constant for the air is have the 1. Okay, so always the dielectric constant is range from to the 1 to 10. Okay, so this is about the capacitor. So now we'll talk about the, if the capacitors in the series, parallel, okay, so how it will be calculated, then we'll discuss about the what are the types of the capacitors we'll have. So suppose here considering the three capacitors are connected in series. Okay, so three capacitor is connected in series. So when we can say this capacitor series, then so positive, negative, positive, negative, positive, negative. If they connected, then it can called as a, or three capacitors are in series. Okay, the charge. Okay, so the charge of the capacitors we can indicating the Q, and capacitance of the each capacitor C1, C2 and C3, so which are connected with the voltage source. Okay, so here in the capacitor the voltage, so whatever the voltage source we are connected, the voltage source is always different. Okay, so the voltage in across the each capacitor will be different. That is the V1. Here the voltage across the capacitor is V2. The voltage across the capacitor is V3. Okay, here, so from that one, the voltage, total voltage across the three resistors, that is equal to, we indicate the V is equal to V1 plus V2 plus V3. Okay, so here V, so we can say that is meant by V1. So here is V1 is equal to, So we are writing that is a Q directly proportional to V. Okay, Q by V is equal to C, right? Similarly here V1, okay, if take the V1 is equal to Q by C1. Okay, similarly V2 is equal to Q by C2. Okay, V3 is equal to Q by C3. So here we are taking that is V1, V2, V3. Okay, so we are writing as a Q by C1, Q by C2, Q by C3. Okay, we are taking the Q as a common. So then we get the C1, 1 by C2, 1 by C3. Okay, so here is a V is a common, right? So V by Q is equal to 1 by C1, 1 by C2 plus 1 by C3. So here what we are writing? So V by, okay, so Q by V is nothing but C1. Okay, so V by Q is nothing but 1 by C. So we can write there is a 1 by C1, 1 by C2, 1 by C3. Okay, similarly we write as that if the capacitors are connected in series, total capacitance is that is 1 by C1 plus 1 by C2 plus 1 by C3. Okay, so we can write this equation, that is the CT is equal to, okay, product. Okay, so product by sum. So product, so first we'll at the top it will come the product, then it after it will come the sum. Okay, so always remember that. So at the top the product will come, after that sum is come. Okay, C1 C2 plus, okay, so C1 C2 C3 by C1 C2 C2 C3 C3 C1, like that. Okay, so this is for the series. If capacitors are connected in parallel, so capacitor is connected in parallel, so here we can assuming the three capacitors are in connected positive to positive, negative to negative, and which are connected to the voltage source. Okay, okay, so the voltage source. So here the voltage source is voltage across the each capacitor is same. So if the C3, C2, C1, okay, so Q will be different. So here Q2, Q3. So similarly in the resistor, okay, so what happened in the resistors if connected in parallel, that is the current will be divided. Okay, similarly in the capacitor also the current, okay, so here as we can say the charge, okay, charge will be different. So connect in series the charge will be same. Okay, so here we can write by taking this, so we can write the positive Q is equal to, okay, so Q1 plus Q2 plus Q3. Okay, so Q is equal to, okay, so here Q directly proportional V. Okay, Q by V is nothing but C. Q is equal to VC. Okay, for each one, so Q1, Q2, Q3, so we can write that is C1 V, C2 V, C3 V. The voltage across each capacitor is equal to the supplied voltage, that is a V. That's why I take as a V. Okay, so C1 of, sorry, so we can write as the voltage of C1 plus C2 plus C3. Okay, so here Q by V is nothing but C1 plus C2 plus C3. Okay, so here Q by V nothing but C. So we'll write total capacitance in the parallel is equal to C1 plus C2 plus C3. Okay, this is formula for the parallel connection of the capacitor. So series nothing but 1 by C. Okay, parallel nothing but sum. Okay, that is the if the capacitor is connected in series and parallel. So let me go to this one first. So basic, so topic, the capacitor. So capacitor nothing but the two surface charge particles. If let's take, that's the two surface particles, metallic parts, is separated by one insulating is called as a capacitor. Okay, so here the capacitance. Okay, so capacitance depend upon the insulating medium and distance between the two plates, and the plates will having the insulating medium is called as a dielectrical medium. So dielectrical may be air, paper, impregnate paper. So not only like that, so in the so the capacitor will store the energy in the form of the charge. Okay, so what will do? The capacitor will store the energy in the form of the charge. Okay, so store the energy in the form of charge. Okay, so that is the charge indicated the Q. So the charge is directly proportional to the supplied voltage. That is the Q directly proportional to V. Q by V is equal to proportional constantly of the C. So where C is the capacitance. Okay, where C is the capacitor. So we can also say that the ratio of the charge particles is directly proportional to the supplied. Okay, the ratio of the conducting plates is the charge is the directly proportional to the supplied potential flow across it. Okay, so we can, that is Q directly proportional to V. Okay, so the units of the capacitor, capacitance is the farads. 1 farad is equal to 1 coulomb for volts. So farads mainly in the units, that is the micro. Okay, so microfarads will be all. So dielectrical current. So dielectrical constant depend upon the material which is made. Okay, so the material is nothing but here medium. So based upon the medium, the value will be changed from 1 to 10. So dielectrical constant of the each insulating medium, that is the dielectric value. Dielectric will have the different, that is air, paper, pregnant paper. So for air, the value will be having the 1. And if the series, okay, so capacitors are connected in series, nothing but the charge will be same in the all the capacitor, then the voltage across the each capacitor will be different. So the series, okay, if the three capacitors connected in series, then we can write the formula as total capacitance, that is 1 by C is equal to 1 by C1, 1 by C2, 1 by C. So similarly you can write as the product, okay, C1 C2 C3 by C1 plus C1 C2 plus C2 C3 C3 C1. Okay, so nothing but CT, the total capacitance is equal to product by sum. Then similarly parallel, okay, so capacitors connected in parallel, we can write as the charge will be divided for the each one. Okay, but the capacitance also will be different. So here we can, the voltage across the each capacitor will be supplied potential difference. Okay, so from that one we can write Q is equal to Q1 Q2 Q3. Okay, so here Q is equal to Vc. Okay, so we are using that. So from that one we can write the parallel connection of the capacitor, Ct is equal to C1 plus C2 plus C3. So this is about the today lecture. So